रूट ऑफ क्वांटिटी एक्चुअली देना पड़ेगा.
Hello. Please settle down or we start the session. Open your laptops. We have set the link for the mashup. Please open it. We are just sending it. So first, just let me know how many of you are familiar with binary search, like just searching algorithm. I hope everyone is familiar with that. What's the time complexity of binary search? Log n, right? So that's why we use it over linear search. So what's the condition to use binary search on an array? Sorted. It should be sorted. So Just this is the code for normal binary search. I hope everyone is familiar with this. Is there any doubt in the normal binary search algorithm? Why is it log n? Does everyone understand that? Because we halve the search space after every iteration. So that's why it becomes log n. So I hope everyone knows this and moving ahead. Okay, so how many of you are familiar with lower bound and upper bound? Okay, so lower bound basically means in the searching algorithm, basically we search for a key, whether it's present or not present. But lower bound means we search for the lowest element, which is the greatest for that key. So suppose if our array has 1, 2, 3, 6, 7, and if we want to search for 5. So n here is 5. So for k equals 5, what should be the answer of the lower bound? For normal binary search, it will say it's not present in the array. But lower bound algorithm says the greatest number which is lower than the key, which is 3 in this case, because 5 comes in between 3 and 6. So this is what the lower bound algorithm does. This is the code for that. It is very similar to normal binary search. So basically, at every middle index, we just check whether it's less than equals k, our element which we have to find. If it's less than equals k, it could be our prospective answer. Wait. ये upper bound है ना? ये code. So this is upper bound, it's just the opposite. So instead of 3, it will print 6, which is the element just greater than our element which we want to find. So in this case, it will print 6. So if our middle element is less than equal to our key, we don't require that anymore. And since our array is sorted, we know any position less than n as well, we don't have to access it and check it. So we can safely eliminate that. So we can just make our left pointer m plus 1. But if in the else case am is greater than k, we need to check whether it's a prospective answer or not. So we save it in another variable and then we reduce our search space to half. Does everyone get this? Any doubts? So in this case as well, the complexity is log n. So because we are reducing the search space by half at every iteration. In one case we move the left pointer, in the other case we move the right pointer. So any doubts, please ask.
Could you explain this part like
the while loop?
Yeah, basically while loop.
So
I didn't understand how you adjust the left pointer.
Okay. So it's initialized at 0 and n minus 1. So at the first middle element, it's just checking whether it's less than equal to our key or not, the one we have to check for. So if it's less than equal to that key, that means we don't require any positions less than m as well. So we can safely skip all those positions and make our left pointer one greater than the middle. Because we need an element just greater than our key. The first element just greater than our key. So we can safely eliminate all the positions less than n, including n. But if it's greater than key, then we don't know for sure whether it's our final answer or not. So we just store it for a while and then we reduce our search space. So suppose in this case, I was searching for 5. So when my middle pointer reaches 7, suppose, it will see that it is greater than 5. But we don't know if it's our right answer or not. So the answer just stores it for a while and then it reduces the search space. Then it doesn't check for elements 7 and greater than 7. It checks for lower. So that's the logical. Is it clear? Any other doubts here? Okay. Then you can open the mashup. Open this question, building an aquarium, and just read it. I think many of you have already done this. We had asked it in the interviews as well, as far as I remember. Okay, so I'll explain the question. So basically, we have an aquarium, and each each position has a height associated with it, and we have to fill water inside it, and the volume of water is already given. So we need to find the height at which the water will stagnate, so that we know the maximum height of the aquarium we have to fill. So that amount of water is already given. Now, if suppose I give you a particular height, say 5, can you calculate the amount of water required to make it? Just think on that line. If I give you a particular height of water, the aquarium has this much height of water, can you find the volume of water which is in the aquarium? If anyone has any approach, feel free to discuss. Since this is a binary search session, obviously this involves binary search, but I hope you can see this is not a generic binary search like the log n one, just finding the thing. You need to modify that a bit. Anyone? कोड करने से पहले अप्रोच बस बता दो. इसका ब्रूट फोर्स सॉल्यूशन आया किसी को? हाँ
मतलब n log n शायद वर्क करेगा.
कैसे?
पहले हम लोग चेक कर लेंगे. आप क्वेश्चन को रिपीट कर सकते हो?
हाँ तो में ऐसा कुछ है उसमें हमें वॉल्यूम ऑफ वाटर गिवन है. वॉल्यूम इक्वल्स x और whatever. वो यहाँ पे कोड करना है इसको, फिर दिखाना है कि वो कहाँ पे स्टैग्नेट हो जाएगा। ये भी हो सकता है, ये भी हो सकता है, कुछ भी हो सकता है वो, वही हमें मैक्सिमम हाइट वो पता करनी है। ये
एच के लिए हम सर्च कर लेंगे, एच सैंपल स्पेस होगा और एच के लिए लॉगिन में वो
लॉगिन में कैसे करोगे?
एच में सैंपल स्पेस रहेगा 0 से लेकर एक मैक्सिमम हाइट।
हाँ ठीक है,
और फिर लॉगिन से मतलब डिवाइड करते जाएंगे और फिर जो बीच में नंबर आएगा उस पर चेक करेंगे कि कितना पानी भर रहा है और वो एक लेवल पे है या नहीं है। अगर हो रहा है तो फिर आगे
करेक्ट। हाँ, जिसको नहीं समझा, I'll explain it. So basically, this is what is known as binary search on answer. You will have a search space which you have to identify. इस केस में we need to find the height. So our height is the search space. So इसका अगर brute force solution बताए तो height can go from 1 to whatever the question says, 1 to 189 or something. वैसा कुछ है। तो brute force क्या होगा? Just iterate over entire this search space. Find the volume of water for each height. वो कैसे निकालेंगे इस एलिमेंट? If suppose I say मुझे height यहाँ तक भरना है, this is 1, this is 2, this is 3, h equals 3 तक पानी भरना है, then how much water will I require?
Sum of differences.
Sum of differences. But what about this case? यहाँ तो कोई water
उस केस में फिर 0 होगा।
हाँ, तो basically वही है। Wherever this AI is greater than h, this case we ignore. We just take a summation of h minus AI. Is it fine? Just h is the amount of water which you have to fill, the height, and AIs are this. So if AI is greater, we don't have to consider that because water can't fill that of the equation. So just we take the summation of the works which are less. Any doubts here? So इसका क्या type complexity होगा? This is O of h. But अगर we iterate over the entire h, and for this every h we calculate this, इसका क्या type complexity हो जाएगा? H of into n of n, which is very high. It won't work. So I hope everyone gets key. If we iterate over entire h and then we find the water required for every point, then we can get to the answer. Because at the point where the volume which we calculated, if v is greater than the x given, that means we have to take a height one less than that and we are done. Any doubts here? We are iterating over entire h. As soon as we reach an h where the v of h is greater than x, we know for every other values of h, amount of water required will be more. So we don't have to check further. So our answer in that case will be h minus 1. We just break out of the loop whenever this condition becomes true. Any doubts here? So now, how do we reduce this time complexity? That is the question. Here where binary search on answer comes into play. In normal binary search, why could you apply binary search there? Because the array was sorted. So similarly, wherever binary search on answer comes into play, we need to find some kind of that kind of a behavior. So suppose we take a graph like this, and we plot a function. Suppose for all elements AI, we plot the identity function f of x equals x for all AI, and it's a sorted array. So what would the function look like? It would be like this, like this, like this. These are the AIs. I equals 1, 2, ये clear है? It's a sorted thing and it's a fx equals x function. So it would be a increasing function. ठीक है? Now, question हमारा क्या बोलता है? There is a key which we have to find. That key is this somewhere in this y value. This is our x value. So suppose we need to find this. अब यहाँ पे we know कि whatever middle element which we are finding, if it's greater than this value, we can ignore everything away from it. Because this function was an increasing function. It's not a random function. Intuition आ रहा है इसका? Suppose we need to find this. यहाँ पे कुछ है नहीं तो we don't get anything. But इसका lower bound why could we find? Because it's just lower than this. तो basically binary search on answer का यही condition होता है. The function should be monotonic, whether it's strictly increasing or decreasing. तो question में it's usually given कि हमें volume equals x के लिए find करना है, and this you can consider as the height. So as you could see, for a particular height, you could calculate a volume, and we noticed that for one height, if this is the volume, for the height greater than 1, the volume would be greater than that. This was an observation, right? If we increase the height, the volume required increases. So we could plot it in a function like this. It is not fx equals x function anymore. This is something like volume of h equals whatever y. So if we plot that function, we know it's an increasing function. It will keep on increasing for increasing values of h. We plot it here. And in the question we have been asked if v equals x पे what is the corresponding h value? This is the question basically. Just need to find this there. Now if anyone can think. So we have been given कि we have at most x water, x volumes of water. So for any height less than this, we can fill it in the aquarium. For any height more than that, we can't. So इसमें कुछ binary search जैसा intuition आ रहा है. Binary search में भी we used to do the similar thing. कि if a of m is a of m is greater than k, then we could remove the entire right part and we could just skip everything. So in this case as well, if suppose for a particular height, we know that the volume is greater than x. Now, do I need to check for any height greater than h then?
No.
No, right? Because it has been established that for as the height increases, volume increases. So if for this h, the volume required is greater than x, for any h greater than this, the volume would be even higher. So we could skip the searching for all those values. Now if for a particular h, volume is less than equals x, can we say for sure this is our final answer? No, right? But do we have to check for values less than this h? No, because it has also been established that as the value of h decreases, the volume required also decreases. So if for a particular h I could find that volume it takes is less than equals h, do I need to check for anything less than h? No. Now if anyone could come up with a conclusion.
Upper equal to min minus 1, lower equal to min. Then if
Basically, what are the conditions in the binary search? You check a value, you check the value which was given in the question, and accordingly you take some action. You reduce the search space or something. So in this case also, this is the condition we have found. So what changes do we have to make here to accommodate this? Like I said, the basic binary search uses a function. You could say fx equals x. We were searching there. Here the function is finding the volume.
कौन से कंडीशन पे हम बाहर निकल रहे हैं कुछ
Anyone wants to discuss? Any ideas? Anyone?
वन थिंग आपका रिपोर्ट में वो बात तो नहीं कर सकता
हाँ
बट वो हमेशा
Do you want me to explain it again? So I think we should discuss the solution now. So this is the code for the question. So basically we start with this usual thing. We take a L value, we take a R value. The range we will get back later. And we take an answer variable. Now the loop is similar, L less than equals R. We take the middle value. Similarly. Whether could anyone say why are we using L plus R minus L by 2 and not R plus L by 2?
कम करके वो बड़ा होता है
उससे क्या होगा?
मुझे बाउंस पे नहीं आता
हाँ, correct. So it might happen that R plus L is a very large value and it could overflow. Suppose L and R were something like 2e9, they are inside the range of integer. But when we do L plus R, it becomes 4e9. That's outside integer. So it results into an overflow. But if we take this approach, R minus L is a smaller number, so that won't happen. Okay. So basically, this L and R are the search space of the height which I am talking about in the x-axis. So we are taking the middle element from our search space. Now this is the function which we discussed. Finding the amount of water which we need to fill up to h height. Mid is the h here. So this is the exact condition which we described there. If ai is greater than h, we don't do anything. If it's less than h, we add the difference. This sum is the amount of water which we need. Now this condition, this is what we talked about. As we said, if the volume which we found is less than equals x, we can skip the entire lower limit, because we know for any height less than that also it will require less water, so we don't have to check for it again. And else condition, if the volume required is greater than the volume which we have, then we don't need any height greater than that height as well, so we can skip the entire height now. Does everyone understand this? इतना छोटा सा ही बस कोड है. The only difference between this and the normal binary search was, in that you were comparing it with the value of the array directly. Here you are just doing an operation on the entire array. You are doing the operation, finding the sum and just checking whether it's less than our target value or greater than our target value. That is the only difference. And the question asked the height which we need, the maximum height which we could reach. So before skipping the entire left part, you just store that height to check whether it could be a prospective answer or not. Then you move on to check for the rest of the half of the search space.
नया मेड जो है उसके हिसाब से देखना पड़ेगा हर बार नया बेड आ रहा है उस बेड के हिसाब से अलग वॉल्यूम निकलेगा कैसे करेंगे
So what binary search on answer usually looks like is this.
अरे वो बेसिकली कितना
So as I said, we have to
हाइट
iterate
में
through the
कितना
entire
वॉल्यूम
height.
रहेगा वो फाइंड आउट
You have to check whether the volume which you calculated was less than equals x or not, whatever it was given. So if it was less than x, it would give a true value for h equals 1. If suppose for h equals 2 also it's 2, it is here. Now we move on to 3. And if you find out that the volume required is greater than the volume given in the question, it results in a false. But after this point, you know all other heights greater than this would also result in a false. So 4, 5, whatever, 1, 9. 3 false, 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 false. So do we see a pattern here? It's something like true, 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 false, 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 false. For a particular part, it will be true, then it will be false. This is the monotonicity which I was talking about. Either you comprehend it this way or this way. This is basically the volume function, and this is basically volume less than equals x function. If volume less than equals x, then true, otherwise false. So the question had asked the highest value for which it was true. Any doubts? Do you want me to re-explain any part? See the code once. Get a feel of it. Just fill out this attendance for first.
नहीं लेकिन इसमें ये होंगे जो AI ग्रेटर देन मॉडल वो तो नेगेटिव जा रहा है फिर वो उसमें कंडीशन था if AI is greater if AI is lesser than or equal to lesser than कंडीशन था इसमें तो कंडीशन लगा पहले था ठीक
Password
fucking
खोल लो पहले पासवर्ड के बाद मतलब बंद कर दूंगा मैं 10-15 सेकंड
सबने स्कैन कर लिया
नहीं
जल्दी जल्दी
अच्छा वो आ गया
अभी कोड नहीं हो रहा है तो इट्स फाइन बस लॉजिक समझ लो जाके कोड कर सकते हो
वो तो कंडीशन लगा ऑटोमेटिक मतलब सिर्फ वो एज ले जो एज से कम है तो सही है लेकिन फिर इसमें एन भी गलत है नहीं एन चेंज कर इन द सेंस दैट कि तू चेंज कर रहे हैं यहाँ पे 10 समझ की मिनट से कम है और 5 मिनट से ज़्यादा है
Everyone open the form.
n is equal to 10 not 15
Everyone open the form and enter your the password. Yes. Anyone hasn't opened the form? अभी बता दो. The password is binary search all small close spaces. Binary search.
all small no space
closing the form in 5 4 3 2 1
गाइस कुछ तो डाउट होगा. आई डोंट थिंक सबको एक बार में समझ आ गया होगा. प्लीज पूछो. Just see the similarity between this and the lower bound code which we wrote. It's entirely the same, just this function is different. Our checker function. मैंने यहाँ पे just array का value से check किया और फिर वहाँ पे बस summation लेके वो बस differences check किए. बाकी पूरा same code है. There is nothing special in that. The only thing which you have to know here is why could you apply this concept here? This is because of this monotonicities.
So I was limit book, but mine is working when I do r is equal to bit, not r equal to bit minus 1.
It is working.
With only bit, if I do bit minus 1, it's not bit.
Then in the same code, everything is should it have? This is an accepted code, so have you used something like r minus l less than equals 1 or something like
I did
that?
r l less than
Okay, one more important thing when providing such an answer. Guys, just listen out. This is even I have faced this error.
Oh, and this.
Sometimes, like what I have done here is I have kept a sum variable which stores the amount of water I need, right? Now, what can happen is this sum variable can go out of bounds. So, what can happen is if you've taken an int, let's say, and your height is 1e9. And you have 1e5, let's say pillars or whatever, blocks. So you could have a certain test case where in the sum, A of I is 0 for all, and your mid could be 1e9. So you're summing up 1e9, 1e5 times. So your sum variables will go out of bounds. So I suggest you use long rather than int, or you keep a break condition. So you can say so what we're doing here is if sum is less than equal to x, so you can say if sum is ever greater than x, then you can directly break. So you will never go out of bounds. Everybody understood the out of bounds part? Yes? So yes, just stick to long, or I would suggest you keep a break condition here, because there are some questions, like there's one particular question where even long gives you an error. You have to use something long. So just keep a break condition.
So as he said, we don't really need the exact value of sum, we just need to know whether it's greater than or less than Rx. So now coming to this, the values of L and R. This is basically the entire H's value which you want to check for. Previously we were just doing a loop from L to R for all the values of H's. This is the same limit. There's nothing special here. From the height you want to start, from the height you want to end. Just you are doing a binary search on that. So the question had said, the question had the limit of the volume is 1e9. There could be a case when n equals 1, ai equals 1, and x equals 1e9. So there's just this one unit. Your volume is 1e9, and the height is 1 something. So you will add all the water here. So what's the maximum height you could reach?
1e9 plus 1.
1e9. So you can keep your r as 1e9. It doesn't really matter if you take a little extra, but you could do it with 1e9 as well. More accurate is 1e9 minus 1. Like height is 1e9.
To be safe, you can just go 1e10, 1e11.
To be safe, we just take 10 times
When
extra.
you're logging it, it doesn't really matter. Also, whoever wants to leave for dinner and is giving the contest, you can feel free to leave. So,
We won't discuss any new concepts now, just another
yeah,
question.
I will just do some more questions on binary search.
Oh, we are discussing an interactive problem after this, so if anyone wants to learn that, please. Okay, I'm assuming everybody gets this. कुछ भी डाउट हो कभी भी ग्रुप पे या कहीं पे पूछ लेना. Now move on to the ruler question. Ruler easy वाला जो भी नाम है उसका. Read it once. Don't get scared with this word interactive problem. Just first understand the question. Okay, so I'll just explain the question. You are given a ruler and it's fixed that it has a length of 999 units. It's fixed. Now the question says the ruler has skipped one of the units, one of the points. So if suppose 2 was skipped here, then it would have been 1, 3, 4, 5, 6. Similarly, here 4 is skipped, so it's 1, 2, 3, 5, 6. So you can say if we want to measure the length of 4, it will give a wrong reading. To measure a length of 4, it will result in 5. So this is what the question, this line means basically. If you want to measure a length of 3, it will give a correct answer. Because till then the skipped part hasn't reached. After the skipped part, it always results in a +1 value. Is everyone fine with this? Now the interactive part of this question is you could query in this way. You can give 2 integers as the parameters and it will give area, the product basically. However you can interpret this, it will give product of A and B as measured by the ruler. It will measure A, it will measure B. So if suppose A was greater than that skipped value, it will result in A plus 1, right? If B was also greater than the skipped value, it will result in B plus 1. So instead of returning A into B, it will return A plus 1 into B plus 1. So whatever query you give, it will give the area, corresponding area as measured by the ruler. If both A and B were less than the skipped value, it will result the correct answer A into B. So though, if you don't know about the interactive problem, just think of the approach which we could use. Once forget about this 10, that match 10 queries, just think about the approach. You need to give such queries so that you find the skipped value. The skipped value is in this range.
उसने फॉर्मेट ऐसे नहीं किया ऐसी क्वेरी कर सकते हो तो इनपुट्स का फिर लगा सकते हो मेरे हिसाब से लॉग करें क्या है लॉग 1000
just think of the same pattern which we discussed here. Here as well, if we want to measure a value greater than the skipped one, it will result in a +1 value, and if it's less than the skipped one, it will result in just the same value. Is everyone clear with the question?
मैं तो बस यही सोच बनाए
How many of you are actually trying this question and not studying the aquarium?
एक चीज कुछ एबी को सेम कर
Rest all are in aquarium.
प्योर बाइनरी सर्च हो गया तो एकदम ए को 1 बी को सर्च ಮಾಡ್ತಾರೆ प्योर बाइनरी सर्च तो कुछ है ही नहीं तो हमेशा ही करना
Oh, this is introduced in your every time based on my
Aquarium में doubt है तो पूछ लो. I'll explain to everyone.
what happens if a measure the length which is greater than the number. He asked for
Guys, aquarium नहीं हुआ फिर भी एक बार ये सुन लो इसका approach. This is simpler than the aquarium. Just forget about the interactive things कैसे implement करते हैं. Just see the main logic. There is no other input in the code. You know the length of the ruler is till 999 and a skipped part का range is 2 से 999. तो उस पे ही हमें सर्च करते हैं. So basically, if we were allowed to take many queries, unlimited queries, we could use a loop and check for each and every value. So just tell me if I do a query of question mark 1 and m, what could be the answer? Anyone? If I ask the query 1m, query had two parameters, right? A and B. If I,
m or m plus 1.
It could be m or m plus 1, right? Because into 1 is constant. 1 can never be skipped, it's given in the question. It says the skip part is greater than equals to. So the answer to this query, just believe me on this, this is asking the query and getting the result. So 1 comma m है, so it can give either m or m plus 1 depending whether where the skip part lies. So this is just checking that. This x greater than m is basically checking whether the answer which we got from the checker is whether it's m plus 1 or not. If it's m plus 1, that means the skip part lies less than m. So we can reduce our search space less than m. We don't have to check for values greater than m. We can skip everything. Because we know it for m, the value skipped, for any value greater than m, the value will be skipped as well. This is basically x equals m plus 1. So I can safely reduce my entire search space. I can reduce the right part. Now just this is the alternate condition. If x is equal to m, that means we haven't reached our skip part yet, and we have to check for the skip part for greater than m. Because for lower than m also we know that the skip part can't lie there. Any doubt? Do you want me to re-explain any of these 4 lines? This is just a 4-line code. The same logic is applied here. You have a checker thing, and then just you check which part of the search space you have to reduce. If you know something for m, you know that thing for greater than m as well. That's why you don't have to check for those values again. You just reduce it.
What is the search space? The search space area. How is the search space missing?
No, your search space is missing. So that's the reason value. See, what this is going to return. So now this is also going to return m plus 1. We can run it. So yes. So if it returns m plus 1, then this gives you also skip an otherwise you search skip. Also this
Without this question, I hope this is easier than that aquarium one. This 1 comma m is basically converting that area into checking whether this m part is skipped or not. M lies after the skip part or before the skip part. This is just a shortcut to get that. We did binary search over here because we didn't have the liberty of unlimited queries. Nothing else. Otherwise, we could query for all n till r and get the skip part.
जो आज क्वेश्चन है मैंने उस पर ये लिखा है कि क्या होता है क्वेश्चन मार्क फिर इनपुट
If any of you is interested in the how did I implement the interactive thing, it's nothing fancy, just this. You just query it question mark AB normally like the output.
just say plus one.
हाँ उसमें बात आता है. Just then you have to take input of the thing, the answer which the checker would give you. nothing else. Now, one thing you have to keep in mind is that usually when we use this fast I/O thing, the output doesn't show in the terminal as soon as you see out it. It shows all of them together after the program ends. But for this, you need to output each query before the program ends. So you have to use endl instead of \s. So that ensures that this cout sentence gets printed before the program ends and then and there when this sentence comes in. Nothing else. Instead of \s, you have to just use endl. Nothing else. No other change is required for an interactive problem. Instead of writing a function, you could write this here as well, but I will find it easy. Coming to the time complexity of this, the question and ask key, we can at max ask for 10 queries. How are we ensuring that? Respond, please, anyone respond.
Search space what for that is 10 queries.
Yes. So basically 10 queries go there. So that means this ask function should be called at max 10 times. And as you know, time complexity of binary search is log n. And log n part is the size of your range. So if you could just approximate this range to 1000. So the number of steps, the maximum number of steps it will go through is log of 1000. Here log is base 2. So log base 2000 is less than 10 basically. So this loop runs at max 10 times. For that aquarium thing, the time complexity of this would be a log of this range times the time complexity of each iteration. The time complexity of each iteration is O of n for this checker function. So it's O of n into log of 1e9, whatever that is. There was no checker function, so the 10 part didn't come up. So it's just log n. Okay.
आइडलनेस लिमिट एक्सेल कर रही है। हाँ आइडलनेस लिमिट एक्सेल फ्लश किधर डालना है क्या
नहीं डालना,
नहीं डालना
जस्ट यूज एंडल।
अच्छा फिर भी दिखा रहा है आइडलनेस
Maybe have it here. No, 2 plus 3 doesn't come.
Oh, is that it?
Yeah, what is
I think
That defy the whole point of
Guys, the session is over. Lots of us are going to the lab to give the contest. You want to give the contest from the lab or from your room, or not giving it to me, fine. But yeah, we are opening the lab.
Ishan, I want to modify my template. How do I do that?
Go to modify. Go to settings in VS Code bottom left. Go to snippets. There's an existing one, right? C++. Yes. That's it.
Plus, I got JSON.
Yeah.
Type def endel backslash because इसकी वजह से I always use endel by default and
No, this will not give an issue. We had put this in our code simply for interactive.
so then flush.
You don't need to flush. You have to just remove this. Just remove these lines. Remove faster. So these two lines are there. Just comment.
And I don't have to change endel, right?
You don't need to change anything else.
So I can use the same code.
Yeah. So just comment on these two lines. There.
Thanks. Maybe it's really Where is missing? Oh, smart. That's right.
Yeah, see, I use the See, even if I
heartbeat चल रहा था plus 100
actually, did you try?
for 2 days. I don't care if we go now.
As in, like, even basic stuff, like, I don't get why VS Code where it shows the wrong thing. I don't understand that.
One more question.
Yes.
For interactive problem, is there any way to verify your code before submitting it?